Alright, so I'm going to go over a few example problems that'll help you with like 46, like I crossed off from the homework yesterday, and 52, which I didn't think you would know how to do, because, well, I didn't think you'd really get 52, and then 53, so I'm just going to cross those off. So the homework, technically from yesterday, that'll just be one assignment right there, 19 through 40. And then the one I add on will be today's, and Mrs. Richens on Thursday will check both of those. So that should just be one, and then the one I give you today will include those. Okay, so like 46. Here's one that's like, I just made this up. Got a function here. Few different letters in there, but it's okay. I just tried to make this one kind of similar to 46. We can do this. If I tell you to find dy dx, that means find the derivative of y with respect to x. Kind of like when you type it in the graphing calculator and you have to put y1 comma x, that whole respect to x thing that Brenna says is annoying when I say it. Well, this is why you have to say it. Because if you have more than one letter in here, you have to know which one you're taking the derivative with respect to. So like this one, I'm doing it with just to the x. And we're going to assume in this that v and z are constant. That means they don't change. That means they behave like just a regular number. Okay? So that's all. I mean, we got v's and z's. Those are just going to be like regular numbers. They're just constants. You can imagine that as like just a single number on top, and all we're doing is the derivative with respect to x. My assistant thought that was funny. What do you think? Think they'll know how to do it when we're done? Yeah. Hopefully he doesn't get. He's getting crabby. Hold on, wait till I finish. Okay, so you just got to do this, and you go through, and you're like, okay, I got to do the derivative of this thing. Well, it's subtraction, so I got to do the derivative of the front piece. Well, I was going to say this one's division, but it's really not. Whenever you don't have your variable that you're doing the derivative with respect to, like I don't have an x on bottom, so this really isn't like division. I can rewrite this as 1/2 vx. And now I can just use like power rule here. Those are constants. So the derivative of this is just like a number in front of x. Like if I had 3x and I told you to find the derivative, well, power rule, 1 times 3 is 3, x to the 0, so it's just 3. The derivative of 3x is just 3. So the derivative of that thing is just 1/2 v, or you could write it as v over 2. Okay, now this one, well, this one, we'll actually do we could write it as fractions. That's harder on this one when your variable's on the bottom. So we'll actually do quotient rule on this. So we have minus, and then we'll have low d high. That's the way I remember it. So I don't remember how you guys do it. V times u prime. So you take the bottom times the derivative of the top. Well, those are just all constants. 3 times v times z. That's like saying the derivative of 6 or whatever. This is just multiplication. Constant means just numbers. So the derivative of that top is just 0. So I have low derivative of the hot top minus the top, 3vz times, I'm going to put a bracket there to remind myself what's going on. Top times the derivative of the bottom. So down here I have derivative of x squared is 2x. Derivative of 2v, well, that's just a constant, that's just 0. So I got that, and then a bottom squared, so I do x squared minus 2v squared. That's it. Now I could just rewrite that to make it look a little better. So 1/2 v would just be v over 2. That's 0, so I have minus negative this, so that's plus. That's multiplication, so I can write that as 6 vz zx over, and I'll just leave that one like that. So that would be the derivative of y with respect to x for that problem. So in 46 they tell you have to be kind of careful. They kind of try to trick you. It gives you that thing, and it tells you a, b, n, and r are constants. Find the derivative of p with respect to v. But then you have this t in there, and if you're not careful, you might not have noticed at the beginning it tells you gas in the cylinder is maintained at a constant temperature T. So T is also a constant. So everything in there is a constant, except V. So you're just doing the derivative with respect to V. It's pretty easy to do quotient rule on both of those. So that's how you do 46 and 40. I'm going to assign 48. Same thing there. It's good reading there. Let's see. Also want to do another example here. This is different. This is so we got y equals u times v as a function of two, or product of two functions. So u times v, I don't know what those are. We're going to find y prime of 2 if u of 2 equals 3, u prime of 2 equals negative 4, v of 2 equals 1, and v prime of 2 equals 2. So at first glance that might seem confusing, but it's not bad. It says find y prime of 2, so that's just, I just did the yelling thing, sorry, that was probably really loud. So that's just, you're going to find the derivative of this when x is 2, or we don't really have an x, but so all we have to do, we have to do the derivative of this first. So the derivative of that would be, well, it's product, so that's just the product rule. I mean, it's even u and v, so it's just 1 times the derivative of the other plus the other times the derivative of the first one. So that's what we got. Now if we want to do y prime of 2, all we have to do is do 2 on all of them. So like u of 2, we have to do v prime of 2 plus v of 2 and u prime of 2. So we just did the derivative of that. Now we're like, it's almost like plugging in 2 for x. But you might say, what x? Well, there isn't one, but they gave us all this information, and they gave it to us for a reason, so that we would know all of this stuff. Because we know u of 2 is 3, so that's 3. We know v prime of 2 is 2, plus v of 2 is 1, and u prime of 2 is negative 4. So now we got 6 minus 4, so the answer is 2. Y prime of 2 would be 2. So that whole process will help you with number 52. And I'll do another example real quick that kind of do the same thing. So this is actually example 9 out of the book. It says an orange farmer, let's see here, I'll show you how to set this up. An orange farmer has 200 trees, giving an average of 15 bushels of oranges per tree. She's expanding her farm at 15 trees per year. While improved husbandry is improving her average annual yield by 1. So, okay, she's got 200 trees. She's adding 15 trees per year. Her trees are currently giving 15 bushels of oranges per tree, but that's increasing by 1.2 bushels per year. So what is the current rate of increase of her total annual production of oranges? Sounds very confusing, but we just need to define a couple of functions. We'll use t, or t of x. Book does t of x. I usually sometimes just do t. That'll be the number of trees she has. After x years. And then we also need how many oranges she's getting. 15 bushels of oranges. So we can use, I don't know, I usually like to do T with trees, so oranges will use O. O of X. That looks weird. Maybe we shouldn't use O. Maybe, screw it. That's the number of oranges per tree. And that's after X years also. So right now, right now it said she has 200 trees. Well, right now is after 0 years, so we know T of 0 is 200. Oh, I think I said years. We know she has 200 trees right now. That's after 0 years. So that's 200 T of 0 is 200 trees. We also know that right now, O of 0, that's confusing. I shouldn't have used O. Oh well. She's getting, what did it say? 15 bushels of oranges per tree. Let's change it to a B for bushels. There. But then it also said she's expanding her farm at a rate of 15 trees per year. So whenever you're talking about like the rate of change like that, that's like slope, right? The original is number of trees after X years. So that, if you're thinking about a graph, that'd be trees, years. Slope of that, trees per year. So if she's increasing at 15 trees per year, that's just the derivative of this. It's the slope of that. So we can say T prime of 0 is 15 trees per year. And also said the improved husbandry, so she's crossing the trees a little better, and she's getting 1.2 more bushels per tree per year. So that's the derivative of that. That's just B prime of 0. It's 1.2 bushels. I don't want to write the units per tree per year. What were we trying to find? I don't even remember. What is the current rate of increase of her total annual production of oranges? Alright. So all we gotta do is current rate of increase of her total annual production of oranges. So how many oranges, it's hard to say. How fast is she gaining more oranges? Sorry, Barrett's making me laugh over here, making weird faces. Are you pooping? Yeah. So really all we need to do, and I think 52 is more. It's easier. Sorry. So our production, if we multiply, let's see, after X years, okay. To find out the rate of increase of the number of oranges, we just multiply these. This is the number of trees, this is the number of oranges per tree per year. So if we multiply those together, do you guys know how to do dimensional analysis where you have like trees per year? And if I multiply that by oranges per tree per year, I can cancel units here. That's really orange. It's almost oranges per year squared, which is really what it is. Anyway, it's oranges per year. This is confusing. The other one's easier. Shut up. You're making me laugh. What are you doing? Anyway. Just multiply them. Sorry, terrible video. T times B, well, T of X times B of X. Derivative of that would be T prime B plus B prime T. Right? So if we just plug in our values like we did on the last one. T prime is 15, B is 15. Plus B prime is 1.2 and T is 200. 15 times 15 is, what is that? I don't even know. 200 times 1.2 is 240. And I think that's 225. So if we add those together, we get 465. That would be bushels per year that she's increasing her production by. Now, that was a bad example as usual. 52 is much easier. The one you're supposed to do. You got members, and you got like the rent money they're having to pay. There's currently 65 members, so you're going to write two functions. One's going to be, like you could say M of X for members. It's currently 65. It's increasing by 6 members a year, so M prime will be 6. And then you're going to have, I don't know, you can call it cost. So C of X will be 250. But it's increasing by $10 per year, so C prime will be $10. It says, what is the current rate of change in each member's share of the pavilion rental fee? Well, to find the pavilion rental fee, or to find each member's share, you take the total cost and you divide by the number of members, because it says they split it all equally. So you're going to have, if you use what I said and you use, what did I say, C of X, or M of X for members and C of X for cost, you're going to do cost, the total cost divided by the number of members. That will be the how much in each person's increase. I don't know, you can use a letter over here, but you should probably read that question before you watch this to make more sense. So then you just do the derivative of that using quotient rule and plug in all the stuff you know. Okay, I'm done. I think I'm done. Okay. So do those ones. 32, 46, 47, 48, 52 through 58. That was like today. So, like I said, shorten that one to that. Make that one for today. Richens will check both on Thursday. I think I gotta go change a diaper. Yeah. Yeah. Say bye. Say bye. You mad?